A body is acted upon by a force state two conditions when the work done is 0. So the first condition for the work done to be 0 is when there is no displacement. The second condition, when the displacement is normal to the direction of force, that is theta, will be taken 90 degree. Okay, the next question is, what should be the angle between the force and the displacement to get 0 work? So for 0 work, remember theta should be 90 degree, and for maximum work theta should be 0 degree. Moving on to the next question. When a body moves in a circular path, how much work is done by the body? And we have to give reason. Now remember, whenever a body moving on a circular path is acted upon by a centripetal force, right? And this force is normal to the displacement. This force is normal to displacement. In other words, you can say that theta here will be 90 degree. Now let's calculate the work done. Work is equal to Fs cos theta, right? So we can put Fs cos 90. So Fs cos 90 is 0, so the work done will be 0. Okay, now moving to the next question. They say, how are SI unit and CGS unit of work related? Now remember, SI unit of work is joule and the CGS unit of work is erg. So the relation between them is 1 joule is equal to 10 raised to power of 7 erg. This is the relation between SI and CGS unit. Okay, next they say a light mass and a heavy mass have equal momentum. Which will have more kinetic energy? Now as we know that kinetic energy in terms of momentum, it's half P square upon M. This is the formula for kinetic energy in terms of momentum. Now as the question says that here the two bodies have same momentum, therefore the kinetic energy of the two will be inversely proportional to their mass. Because momentum is same, so we can say there the kinetic energy is inversely proportional to the mass. This shows less the mass, more is the kinetic energy. So from here we can say lighter mass body will have more kinetic energy. Okay, now moving on to the next question. Here we have to state the energy changes in the following. See, the first one that they have given us is loudspeaker. So in loudspeaker, electrical energy to sound energy. Then we have microphone. In microphone we have sound energy to electrical energy. Then we have photoelectric cell. In this, it's light energy to electrical energy. Okay, the next we have electromagnet. Now in electromagnet, it is electrical energy to magnetic energy. And then in photosynthesis, light energy of sun to the chemical energy in the plants. So this is the energy conversion that takes place. Okay, the next we have to state the law of conservation of energy. So energy can be created, not destroyed. It only changes from one form to another. State the law of conservation of mechanical energy. Whenever there is an interchange between the potential energy and kinetic energy, the total mechanical energy remains constant. That means potential plus kinetic, their sum will always be constant under the condition there are no frictional forces. Okay, the next we have, what do you mean by degradation of energy? And we have to give an example of it. Here is the conversion of part of energy into an undesirable form is called So example is when electrical appliances are used using electricity, an appreciable amount of electrical energy is wasted in the form of heat energy. So whenever there is a conversion of energy in such a form which is not useful to us, that is called degradation of energy. Now this question says a boy of mass m goes up through a vertical height h. If g is the acceleration due to gravity, then calculate work done by force of gravity on the boy. See, this force of gravity will be acting in the downward direction, whereas the displacement of the boy is in the upward direction. So you are getting an angle of 180 degree here. So if we have to calculate the work done, then work done formula is mgh. Whenever there is a displacement vertically, we say that work done will be calculated by mgh. But as you can see, force and displacement, they are in opposite direction, so work done will be negative, minus mgh. Now in this one, we have to calculate the work done by the boy. See, boy is applying the force in upward direction, whereas his displacement is also in the upward direction. So force and displacement both are in the same direction. So work done will be positive. So we are going to write work is equal to plus mgh. Now in this one, they say a force of friction F acts and makes a body to come to rest over a distance S. Now see, the force of friction always acts opposite to the direction of motion. So again here you can see angle is of 180 degree. So if we have to write the expression for the work done, so work is equal to force is F, displacement is S, and we can see that force of friction is opposite to displacement, so angle will be of 180 degree. 1 cos 180 degree will give you minus 1. So the expression for the work will be minus Fs. These were some important questions from this chapter.